In the first few sections of this chapter, we've been able to solve quadratic equations by incorporating various methods. We've used the square root property and completing the square. In this section, we're going to learn how to use the all-important quadratic formula, which can solve all of our quadratic equations. Let's look at our first problem. We're going to solve the equation x squared minus 7x plus 6 equals 0. Now you may be saying to yourself, hey, that's an easy one to factor. I can factor that to solve. You're absolutely correct. But what we're going to do, just to show how the quadratic formula is used, we're going to use an alternative method to solve this quadratic equation. Now you should have memorized by this time the quadratic formula. Remember, in order to use the quadratic formula, first of all, you must make sure that your equation is in standard form. We can check and see that it is. Once it is, we need to identify the values of a, b, and c. A is the coefficient of the squared term. In this case, that's 1. B is equal to the coefficient of the linear term. In this case, that's -7. And c is equal to the constant term at the end there, which in this case we have 6. Now to use a quadratic formula, let's just write it one time so that we don't forget what we're using. The quadratic formula says that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you have that memorized. That's important in using that quadratic formula. Now that we have our formula written, let's go ahead and make the substitutions for the values of a, b, and c. Now be careful here because notice in the quadratic formula we have -b. b in our problem is -7. So if we substitute in -7 for -b, that gives us -7, or in this case, that's +7, plus or minus the square root of b squared. b, remember, is -7. -7 squared is 49, minus 4 times a, which is 1, times c, which is 6. So 4 times, what did I just say? 4 times 1 is 4, times 6, which is 24. Once we have that calculation, we have to just write this over 2a. And since a is 1, 2 times 1 is simply 2. So here we have x equals 7 plus or minus the square root of 49 subtract 24 is simply 25 all over 2. But we know that the square root of 25, which is a perfect square, is simply 5. So we get 7 plus or minus 5 all over 2. Now what does that mean, 7 plus or minus 5 all over 2? This represents two solutions. This represents 7 plus 5 over 2 and 7 minus 5 all over 2. 7 plus 5, 12, divided by 2 gives me 6. 7 minus 5, 2, divided by 2 is 1. So that tells me that my two possible solutions for this quadratic equation is 6 and 1. You can check that simply by using the factoring method. Now that we've practiced with our quadratic equation, let's try one more. We're going to look at the following quadratic equation. Let's look at 3x squared minus 8x plus 3 equals 0. Again, in this case, our quadratic equation is given to us in standard form. If it was not in standard form, it would be your job to change it into standard form. You need standard form so you can identify the values of a, which in this case is 3, b, which in this case is negative 8, and finally c, which in this case happens to be 3. Now, once we have the values of a, b, and c, we're ready to drop them in to the quadratic formula. X is equal to, are you thinking? Negative b, but since b is negative 8, negative 8 is positive 8, plus or minus the square root of b squared is negative 8 times negative 8, 64, minus 4 times a, which is 3, so 4 times 3 is 12, times c, which is 3 more, or 36. All over 2 times a, but again, a is 3, so that gives me 6. Again, you must have that quadratic formula memorized. Now, the rest of it's just to simplify our radical. We get 8 plus or minus the square root of, we have 64 minus 36, which is 28, all over 6. Again, we're not finished until our radical is in simplified form. In this case, I hope you're getting good at identifying perfect square factors of these radicands. 28 is 4 times 7. So 4 times 7 is the same thing as 2 times the square root of 7 all over 6. Now we're almost done with this. The only thing I see is one common factor. So we're going to go down here and we're going to factor out the common factor of 2. And we're left with 4 plus or minus the square root of 7 all over 6. Once we have that written as a product here, what we can do is divide out these common factors. We have the 2 and the 6. 2 goes into 2 once, 2 goes into 6 3 times, and our final answer is 4 plus or minus the square root of 7 all over 3. It takes a lot of work, but when you really think about it, using the quadratic formula is pretty easy. You don't have to really think too much to incorporate it. You just have to memorize the formula, then substitute the values. Now let's look at one last quadratic equation. And again, we're going to use this method of applying the quadratic formula to our last example here. We've got 5x squared plus 2x is equal to negative 3. Now, I hope you identified as I was writing that equation that the equation is not in standard form. In other words, it's not set equal to 0. So the first step before we can use our quadratic formula is that our equation must be in standard form, which at this point it's not. So to get this equation in standard form, I hope you can see all we have to do is add 3 to both sides of our equation. That gives us 5x squared plus 2x plus 3 equals 0. Now that we're in standard form, we can easily identify the values for a, b, and c in our quadratic formula. I hope you can see easily that a is equal to 5, b is equal to 2, and c is equal to 3. Now, do you have the quadratic formula in your mind? Here we go. X is equal to negative b, but b is 2. So that's negative 2. Plus or minus the square root of b squared, but that's 2 squared, or 4. Minus 4 times a, which is 5, we got 20, times c, 20 times 3 is 60. All over 2 times a, which is 10. Now we need to simplify under our radical sign. X is equal to negative 2 plus or minus the square root of, are you noticing something odd? 4 minus 60 is negative 56. What's wrong with having a negative radicand? We know that there are no radicands in the real number world. So because we end up with the square root of a negative 56, we say this is not a real number. Again, remember, in the real number system, all radicands must be positive numbers. If they are negative, then our square roots are not defined. So this is not a real number. So at this point, since we came up with not a real number, our solution to this original quadratic equation is not a real solution. Now, I bet at this point you're hoping that there are a lot of problems that turn out in this fashion, so you can just write not a real solution. Well, let me give you just a little clue. In the next couple of sections, we're going to learn that this number, although not a real number, is called an imaginary number, and we're going to open up a whole new world of numbers for ourselves, which are called complex numbers. But we haven't gotten there yet, so in this section, whenever you get a negative radicand, you can write not a real solution.